How's it going, everybody? In this video, we're going to be talking about our next inter-AS option, which is going to be option B, or option 2. Now, this is actually one of the easier options to get running. It's a little bit more complicated than option A, which we've already taken a look at, but it's a little bit easier to get into play than option C or carrier supporting carrier or anything along those lines. Now, when it comes to option A or option B, what you're doing essentially is you're taking advantage of the VPNv4 address family, where normally up to this point we've only taken a look at it as an intra-AS connection activation. So the route reflectors will connect down to the provider edge routers via VPNv4. Well, that's not always the case. So you can form a VPNv4 peering with eBGP as well, and that's actually what we do between R6 and R5, and then XR6 and R6. We form those peerings, and then by doing so, we're able to extend the VPNv4 reach between the providers, the provider edge devices. Now, there's a couple of things that need to happen on the PE devices in order to allow propagation of information, because there's extended community values like the route distinguisher, the route target, that need to be extended between the autonomous systems. So there's a couple of different ways that you can do this. The first of which is going to be with the most common way, which is the no BGP default route target filter on iOS, and then the retain route target all command on iOS XR. Now, in situations like that, if you don't already have the VRF configured with the proper import and export route target policies configured, then you're going to need that command, or you turn the ASBR into a route reflector. So you have three different ways of accomplishing that method. We're only taking a look at the no BGP default route target filter command and the retain route target all. It's kind of an inclusive command. It encompasses everything at the same time, so it makes it actually kind of easy to implement and get everything working. Now, when you do that, the other thing that I did in here for connectivity purposes is make sure that on the ASBRs that we set the next top value to the right device. Now, normally you don't have to do that on intra-AS VPN because of the fact that your next hop is going to be the end of the eBGP peering. The problem with that, though, is with this setup, you're actually going to be forming an eBGP peering between the ASBRs, and because of that, the next hop value doesn't get updated through the eBGP update. So if you were not to use next hop self on the ASBRs, when R5 would connect with R6, it would advertise a next hop value of R6's public address, the 164.166 or 56.6 address. Now, that actually would work if you were to redistribute that prefix into the routing so that R1 would know how to get there. But it's easier just to say next hop self and take care of it that way, which is exactly what we did. So once this configuration is all in place and you have everything running, the next step is to understand the label switch path. The LSP itself, there's three of them. And if you look in the blog or in the description below, I've included a link to the blog post that covers this. Because this configuration option isn't very configuration intensive, it's a pretty short blog. But I made sure to highlight the necessary config. So R1 to R5, or I should say the ingress PE, in this case here would be R1, to the egress PE, which is also the ASBR, is R5. So that's your first label switch path. Your second label switch path is between R5 and R6, and your third is between R6 and R11. And they might say, why do I have three LSPs instead of just one like you do with option C and carrier supporting carrier? The reason why is because you have three different next hop values. So in MPLS VPN, normally with eBGP peerings, you do your peerings between, and actually I gotta minimize this a little bit. It's like staring at a flashlight. What you're actually doing is between when you're setting up VPNv4, the next hop updates, so the loopback to loopback, that's where you're forming your VPNv4 peering. So now if you rely on route reflection, it's not that big of a deal because the MPLS router ID, or where you're terminating your your LDP adjacency, is also your loopback. So unlike eBGP with the IPv4 unicast address family, where you need to let your eBGP neighbors know what the next hop information is going to be, which is typically going to be your loopback, you don't have to do that here. But because of the fact that next hop self is needed for the ASBR because of the eBGP update, that's where it comes into play. Now, with normal VPNv4, you're going to form a peering, and you're going to know who, based off of the TCP port 646 connection, your loopback is going to have an /32 host route. So from an LDP perspective, you already know what your next hop is. And because you're going to form your VPNv4 peerings off of the remote loopback, then you don't have to worry about doing recursion because you've already got a label switch path built to that point. With IPv4 unicast, you wouldn't have that. With LDP, it's already accomplished for you. So your next hop value is going to be the ASBR's PE, or your ASBR's loopback. That's going to be your next hop. And then the next hop for that, from there to the other autonomous system, is going to be the directly connected IP address, or your eBGP IP address, to the other ASBR and the other AS. That's going to be your second LSP. Your third LSP is going to be from the ingress ASBR in the receiving autonomous system to the egress PE. So three separate label switch paths. The first one here is going to be R1, R7, and R5. That's our first LSP, and you can tell that based off of a two label stack here, and then the transport label gets popped off and you end up with a VPN label. So that's how you know that one. The second one here is going to be going towards R6. That's your other label switch path. Here you only have a VPN label because the transport label is not needed on directly connected adjacencies. The third one is going to be from R6, well in this case here R10, down to R11. And again we have a VPN label, and we have a transport label, and then we have a VPN label as we get to R11, and then eventually we're terminated on R4. So that's inter-AS VPN option B. That's really all there is to it. It's a very simple design. So just so everybody's on the same page here, we're going to go ahead and I'm going to say the first LSP is R1 to R5, then R5 to R6, and then R6 to R11. Those are your label switch paths. And if you take a look at the blog post, link in the description, I broke that down in a hop by hop perspective on what that was. So I want to keep this video pretty short, other than the fact that it's not a lot of information to cover at the moment. There's other options to use to get propagate the details and stuff like that. But the most common design is the just disabling the route target filtering or enabling XR to retain all route targets that it receives. So two very simple designs. Until next time, guys, thank you so much for watching, and we'll catch you guys in the next one.